Okay.
Can you see people as they come in? Just
Yeah, so people have started joining.
okay.
So we're going to give it a minute, and we'll probably kick off at 1 minute past the hour, just so we can get everyone.
Yeah, that's cool.
A bit of time to join.
Okay, we're just going to give it another minute before we start, just to get everybody in. Okay, hello, my name is Nick, and I would like to take this opportunity of welcoming you all to our webinar. It's great to see some new names and welcome back some friends of Fusion Reactor. So during this webinar, if you'd like to leave feedback, then feedback is really, really cool. And we would love you to leave it in the comments box. Feel free to ask as many questions as you like and use the Q&A to do that. So this webinar will last around 50 to 60 minutes, certainly no more than an hour. First 5 minutes will be me, and then I'm handing over to Mikey. Mikey's going to be demonstrating our new log monitoring feature. He's going to look at the added insight logs give you, and he's going to do that by way of a number of use cases. So he's going to be looking at diagnosing server attacks and crashes to finding errors that logs will find that you may not have been aware of before. I'm then coming back, and I'm going to be talking about where Fusion Reactor is going next. And I'll be talking about how log monitoring fits into our longer term plans as Fusion Reactor starts its evolutionary journey from APM to observability platform. We'll then take a look at your questions. So if you like what you see, and we hope you will, we've all been working really, really hard at this, and we'd like to recruit some beta users. So if you are interested in joining our beta program, then please leave your email address and name in chat, or visit fusion-reactor.com/beta, and we'll get back to you. The beta program will start in probably a couple of weeks or so. So before we get going with our demonstration, of our log monitoring feature, let's take a look at log monitoring and how it will help you become even more effective at finding issues. So as we know, systems within organizations create a huge amount of log files. And the purpose of the log monitor is to make sense of all these log files by ingesting them and giving you the tools to store, to compare, to visualize, to graph, and to analyze them, providing you with deep insight into what went wrong so you can fix it faster. Now, for some time, the team at Fusion Reactor have known that logs would be a useful tool. And today we are introducing Fusion Reactor Log Monitoring, which will be an essential resource for pinpointing and diagnosing problems, and our first step into observability. And I'll be back later to talk about observability. So now I'm going to hand you over to Mikey, who's going to take you through our new log monitoring tool. Mikey.
Hey, so as some of you may already know, my name is Mikey and I am the technical support lead for Fusion Reactor. So for now, we're going to look at the logging feature itself. So we're going to show you what we have so far in logging, where we're going with logging, and some possible uses for the logging feature itself. So the first thing to touch on is what will our logging give you, or why are we implementing this logging feature? So we want to give you further context into your applications and all the systems surrounding your applications themselves. So that's going to include understanding why something has crashed, figuring out maybe why something didn't start or a particular process didn't run, obtaining visual insight through graphing and charting of your logs, aggregating data from the different log sources, capturing data that you wouldn't see anywhere else through metrics or traces. So investigating unregular events. So this could be large request rates where your server's under attack, error spikes, anything like this. So we're going to talk about as well dumping out extra context. So when you're using debug logging and how you can use that in the logging tool. And then also just in terms of looking for hidden errors. So things that might have been going wrong that you had no idea even existed. So the current state of logging. So for the logs, we want to allow you to combine all of your data into a single location. So this includes your Fusion Reactor logs, but also other logs you may want to send. So Cold Fusion logs, Tomcat logs, database logs, system logs, Docker logs, load balancer logs, any logs from any of the services involved in your application's stack. And to do this, we have the logging feature that consists of two parts. So the first part is dashboards. So you can render graphical information from the logs, and then you can analyze trends over time. And the second part is events. So in the events, you can search, process, and manipulate your log files in both graphical and text form to get the most out of the data you are sending. So throughout this webinar, as you see the feature, if you have any feedback, any suggestions, anything you think would be good to implement, add it to the chat, and then we will process this and pass that back to the team. So I'm now going to quickly cover how to get logs into the cloud. And there are two ways of doing this. So the first is through the Fusion Reactor agent itself. So the Fusion Reactor agent, if you have the cloud license, will send your logs to the cloud ingest point automatically. But you have the ability in Fusion Reactor to configure directories that Fusion Reactor will scrape and also send to the cloud. So this could be IIS logs or Cold Fusion logs or anything that's on the system itself. Alternatively, you may want to send us logs outside of the machine of Fusion Reactor, in which case you can use a logging client. So like Promtail, Logback, FluentBit, or any other ones like that. And you can authenticate with our log ingest via an API key and send us any logs this way. So now for the demo itself. And to give you some very quick context, I am running a load balance store. So I have 3 nodes of my store behind an Nginx load balancer. My store logs are being sent through Fusion Reactor itself, and my load balancer logs, I have a Promtail client on the load balancer container, shipping these logs directly to me. I also have 3 load generation machines or containers running just to generate some traffic into my applications. So for the demonstration, we're going to look at 4 user cases. So the first one is a server being attacked in some way. The second is finding background errors that you were previously unaware of. Your third is using logs to provide extra context on application performance. And your fourth is diagnosing a server crash. So we're going to start with the server attack. So I'm just going to trigger that now. Okay, so I've just triggered an attack on my server. And we can see, looking at our applications page in cloud, we've had previous attacks. So we see these very large spikes of traffic come into the server. So it's possible through metrics and transactions to diagnose this issue. So you could obviously use the metrics to see you have an attack, look at each transaction individually, and then eventually diagnose the cause of the attack. But there is a superior way to do this, and that is using the logs of both Fusion Reactor and the load balancers. And it's superior for two reasons. The first one being, using the logs, we can actually use the load balancer logs themselves for diagnosis as well as the Fusion Reactor logs. And the second is, in this case, having the summary information of the logs is actually more useful to us. So we have all the information in one place. It's not distributed across different transactions. So now we're going to go into the logging itself. So when I go into my logging, you'll see we have dashboards and events. And for now, I'm going to go to events. And the first request I'm going to run, I'm going to look in my request logs. And this is going to show me the request logs of all running Fusion Reactor instances right now. So I have 3 stores, and I'll have, you'll see here, currently I'm just running against store 1, but you'll have the same logs for store 2 and store 3. So using this request log processor, we can see we have all of the context of our logs in front of us, but obviously we're still not querying it in the best way. We still could be much more efficient. And we can do that. And that's because Fusion Reactor is using logql as a query engine. So logql can show you the raw files, if you like, but it can also process the files. And we've got an example query to do this that will actually break down our traffic by IP address. So if we run this query here, it's going to take our request log and it's going to process these logs and give you a graph of the hits by IP address. Now you will notice in this log, we have a slight issue. And that's that if we look at our traffic for the particular run of this application, you'll actually see that it's all mostly coming from one IP address. And that's the IP address of the load balancer itself. So in this case, we actually need to modify this query slightly. So using the same syntax, I'm going to apply a saved query where I'm going to use a similar logic, but against my load balancer logs. So now we can actually see the true breakdown of IP addresses hitting my load balancer. So you'll see here we have my 3 load balancer nodes firing, and then when we have an attack, we have a spike of traffic from a singular IP address. And you can see we've actually got one generating now as well in the logs as we speak. So this is telling us who is performing the attack. And obviously in this case, it's one machine performing the attack. It's not a distributed attack. So this is showing us who is actually attacking the server. What we want now to do is look at what is the attacker doing? What pages are they hitting in the application? So for that, we're going to use another query, which is going to process the request log itself. So this is going to process our request log, and it's going to generate graphs for hits against our application page. And we can see when we have these attacks, and we've run quite a few over the last few hours, we can see all the traffic tends to go to our login page of the application. So this is isolating which pages are actually being hit when we have this attack in the first place. So we now have context. We know who's attacking us and what they're doing. What we want to do is make sure that when this attack happens, they're not causing any downsides. So they're not breaching our systems, they're not causing any performance hits, and they're not degrading the application in any way. So to do this, I'm going to modify my query. So I'm going to set it so that my query is simply processing the request log. And because I know the page, I'm going to do a broad text match on my exact URL. And this is going to give me, oops, yep, sorry about that. There we go. Okay. So this is going to give me my request logs. And this, at the moment, we're looking at the last 3 hours, but I could use the time picker at the top to select the time frame. So for example, last hour. Now, what we can do when we have these logs is we can actually process the metrics within the logs. So we don't have to read each line individually. If I click on a log line, it's going to show me the labels and fields attached to this log line. So labels in this case are something Fusion Reactor is attaching. So when you send the logs, it's going to give the job, which would be my instance name in this case, my host name, and my file name, as well as my applications. So these are your labels. And if you're sending through Promtail, this is what you would need to set yourself. What it's also doing is detecting fields. So you see in my log file, for example, we have request ID equals 5501. And that's been detected as a field in this case, Loki and logql itself. Now, because it's a field, what we can actually do is graph the field. So if we click on the graph icon here, this is actually going to generate a graph of, in this case, the CPU time across requests. So we can see here, I had a spike in server 3. So what's that? Around half an hour ago. But when we're under attack, we don't seem to see any CPU spikes. We can do the same, for example, with the free memory of our application. Or with, in my case, I'm not running JDBC, but you could do it with database execution time, for example. And you can do this for any numerical metric-based value. So memory, JDBC, anything like this. What you can also do for things that aren't numerical metric values is you can click the statistics icon. And what this is going to do is break down the individual values. So in this case, it's telling us that even throughout the attack, 100% of our actual status codes returned were 200. We can do the same, for example, with thread name or ID. And that's going to show us that even during the attack, we didn't have an increase in threads being spawned. So the server could process the load and it wasn't too expensive for it. So when you have these attacks, the logs can show you more about where the attack was coming from, because it can take your logs and generate summaries from the data. And you can also use the logs to identify that what you're doing isn't causing any serious defects in any way. So now I'm going to move on to hidden errors in an application. So for a long time, it's been very standard to use debug logging or even just adding logs, say, to your standard out logs in your application to provide extra context for your code. You might have an issue and you just want to make some general dump statements to find out what's going on at the time. Now, we know this approach works, but the trouble is, to use this approach, you actually have to actively monitor the logs of the application itself. And it's possible over time, maybe the habit of checking the logs stops, maybe you replace the engineer and the new engineer isn't aware of these logs, and these logs can stop being checked. So having things like try catch ignores in the code or just adding extra logs, while it can be useful, can sometimes lead to actually missed information. Now, what we can do with logql is we can actually perform full text searches on logs for the system. So I have another example I'm going to run now, where I'm going to search all my application logs for the text exception. And that's just going to show me if we have any kind of hidden exceptions firing in the background we weren't aware of. And in the case of this application, we do. So you can actually see that fairly regularly, we are actually having an array index out of bounds exception fire within our application. Now, what we can do with these is we can click show context on the right here, and that's going to show the logs surrounding this error message. And we can go further down the log here. Now, what we can see is this array index out of bounds exception is actually occurring on our page product.jsp on line 128. So this exception seems to be firing all the time. But in this particular case, it's in a try catch ignore block. So we're logging the error, but we're not throwing the error. So to the user, everything looks fine. And we can actually confirm this if we go back to our applications page. So we look at our store, and then we can actually see, if we look at errors, there hasn't been any for the last, what's this, 1 hour. So even though the code is breaking, we're handling it to make it look useful for the, to look graceful for the user, in which case you wouldn't necessarily be aware of an error unless you check the logs. So what could you actually do in a situation like this? So there's a few things. So first of all, you could enhance the code to throw the error. then you would get the context in your transactions, and you could get, say, event snapshots from Fusion Reactor. You could, instead of that, enhance the logging you have and put more specific debug logs in to find the problem at the time. And you could even look as to say, all right, now I know my line of code is breaking. Let's connect the debugger to my code and let's debug the code, see what's happening. But without the logs, you simply wouldn't have this context to know the error was happening in the first place. Okay, so for my third scenario, I'm just going to grab a quick drink. So I mentioned at the start of the demo, we're running a load balanced environment with 3 nodes. But you can actually see right now, I only have 2 nodes online. If I look for any state of servers, you can see that 30 minutes ago, my third instance of the store crashed. So Java can obviously crash in several ways. You can have crashes where the death is less obvious, let's say. So your JVM may still be operational, but you aren't able to process requests anymore. You may have where part of your application breaks because of some sort of resource limit, but some is still functional. Or you may even have it that your application just automatically restarts on crashes, at which point you don't really notice the crash because if the application takes 30 seconds to restart, it's almost an invisible problem. But these are all still things you need to be aware of so that you can get to the root cause of the actual issue. Now, in my case, this is actually just, I would say, a more common crash. So something went wrong and my JVM completely halted. So I have now lost all metrics to my instance. If I go to my server, I can see that suddenly there is a metric stop. But nothing really happened to spur this metric stop. It just seemed suddenly to stop being operational. I can look at my transactions and I would say, oh, it must have errored. But nothing actually errored in this time frame. So it's hard to diagnose what happens just from metrics and transactions alone. But with Fusion Reactor, I'm actually sending my standard out and standard error logs to the cloud. And this is where my Tomcat's process is going to log any events. So what I'm going to do now is I'm going to go to logging. So I'm going to look at my events. And here you can see I'm running a query, and it's actually processing the standard. It's a wildcard match. It's processing anything that begins with the text standard on my server. Right now, you can see I'm specifically targeting server 3, and it's showing me the final logs before the crash of the instance. So you can see here, we've got, it was processing some account data, and this is a debug log I have in one of my pages. Then you have heap space errors, and you actually see that the process exited. So this is showing me almost the live death of the server. Now your logs, because they all come in on the same second, virtually the same millisecond, they're not always going to be in exact order, but they'll be roughly in the chronological order they send in. So in reality, you would see these lines at the bottom, but because of the same nanosecond, it's not quite going to be able to render that. But we now know we can see what crashed the server. Now, what we want to do is correlate to the facts of, was it in particular this reports page running that did it? And to do that, we can process our request log. So I can just change my file name here to request. And then again, search the logs. And we can see at the time of the server, we had various bits of traffic running in. And then you see this line here is a report.cfm line running, which we can see in the URL. So what we can confirm at the time of the crash is when report ran, that seems to have exhausted our heap in some way. So we now know, or we can at least estimate the cause of a crash from the logs. What we can also do is we can go one step further, and we can actually run a query that sees how often this occurs. So I've saved, again, this query. And now what I'm looking for is the number of occurrences for this out of memory error that seems to be crashing Java. And I can expand the time picker again here to say last day, for example. And we can actually see this wasn't a one-off occurrence. It seems to happen fairly regularly. So it happened today at 4:45. It seemed to happen again at 13:49, at 10 a.m., at 9:40. So it's a regular thing. It's not just a one-off occurrence. So for something like this, obviously when you're having situations where you run out of memory, it's not going to be the easiest thing to debug in the world, but you at least know the rough cause of the crash. And from there, you could look at the reports page code itself. You could analyze, okay, is this code particularly memory intensive? Am I storing large objects, for example? You could add further debug logs. And you could also as well look at turning on heap dump out of memory, so that when your server does crash without memory, you get a report of why it crashed, and you can analyze that upon a future crash. So that would help you to identify the cause of the server crash. And when it does happen, you can at least have some context as to why and what to do as a further action. So my final situation will be on error context. So error context is basically, extra context, I should say, is using the log context just to provide extra details that you really couldn't get anywhere else, depending on obviously where the log is coming from, and is this going to be a tracked metric in one of our systems. So with this, we can run obviously specific logs where we say, show me the occurrences of an out of memory error, or show me when exceptions occur. But you can go a lot deeper than this, and you can actually derive metrics and statistics from the logs you send. So an example of this would be, if I look in my saved queries, I can, for example, look at the average number of bytes returned from my load balancer. And we're on the last day here, and you can actually see, so this is yesterday when I stripped my machine down, there was no traffic. And today, you can see when we have an attack, there is a spike in bytes returned. But generally speaking, if there's no attack, it's not a very heavyweight application. And then we can have other examples of the query. So we could, for example, look at graphing the number of errors that occur per minute and break that down by the job they were attached to. So you can see here, I've got errors in my balancer. I've got errors, and I've got unique errors in my store individually. And here, this was on store 1. We had a sudden increase in errors. So we can obviously get the context from the logs in this manner. The problem is, to do this, you would need to be on this page. You would need to run each query manually, and it's just not a very efficient way of doing it. So that's why we've added dashboards. So dashboards in logs, this is something we internally have used for quite a long time now. And we use it to monitor all our deployments. We can catch any instability that we might be having. We can see problems almost as they're occurring, so we can act on it fast. And you'll see here that I have 3 dashboards. So I have a log rate dashboard, I have my balancer dashboard itself, and I have my store details dashboard. So I'm first going to look at my log rates dashboard. So we see here, currently my time picker is default to 3 hours, and this is going to show me my log rate over the last 3 hours. So my top graph here, this is broken down by the job of the log itself. And we can see here that when server 3 drops off, the log rate returns to nothing. So when server 3 crashes and it doesn't restart, we suddenly lose the logs. When we restart, it comes back up. And we can see that along with the attacks, we see the correlating spike in logs for the server, for access logs, request logs, things like this. We have on the bottom left the log rate over time. And this is a summary, so it doesn't take into account the job. It's purely showing me the full log rate over time. And on the right, we have a graph that's showing me the rate of errors per job over time. So I can see, for example, when I might have had a spike in errors. So we see today that we had a spike in errors in the store balancer around 5 o'clock. And this is all that we can see from just graphing data we have. And this is only in, I believe, 2 log files. So for my next dashboard, I have my balancer dashboard. And this dashboard is using my Nginx error and access logs to actually break down into metrics the performance of Nginx over time. So I can see my IP address hits, which is what we used earlier to diagnose an attack was happening. I have my status codes here. So I can see we're only ever returning 200s, but if I had a spike of 500s, it would be visible. And I can see my responded bytes that are coming from the load balancer over time. Now you'll see this graph doesn't have a spike, and that's because I'm averaging my data points out to the point where my graph is reasonably flat. So I'm looking at this and aggregating by 1 minute. If I change this to, say, 1 second, and then I run again, you'll see we're going to get a slight change in the graph profiles because we're going to have more granularity of the data. Now, what I can also do with these graphs is if I believe I have an issue. So for example, if we take this spike here and highlight the area. Oops, sorry, let me just refresh here. So obviously this is still in beta and we are still ironing out bugs. When this does release in a few weeks, we're planning to kick these out. But at the moment, we still are kind of, fine tuning. But now you see, if we highlight the log area, you'll see what it's going to do is render the logs for that particular area we highlighted. And when we have these logs, we can again click the line and we can run metrics on that line. So this would be our average bytes sent from the load balancer over time. And we can use statistics. What we can also do is if we show the context of the log, we can see the historic context of the log and everything around it. So if you do have a problem, you can go straight from the graph to the root cause of the issue. You don't have to move from the dashboard to the events. It's all integrated together. If you really do need to deep dive into the features, you can click the arrow at the top that says go to events, and this will render that log in text form and allow you then to modify your logql for whatever you need. So I could, apply a filter, for example. Or I could, apply a graph function, whatever you need. That's a number that's not going to work. Sorry. Log in search. Okay, let's use error there. I'm not sure what, but you get the concept. You can take these logs, you can get the logql applied to that, and you can actually then manipulate the logs directly. Okay, so for my final dashboard, what we have is store details, and this is using the Fusion Reactor logs themselves. So you'll see here, some of my queries are more expensive than others, and they take slightly longer. But that's fine, I'm just having more complicated queries. I've got here my top pages hit that we saw in the first example. I've got my graph of errors. I've actually curated a graph that plots points in time where my server crashed with out of memory. So each plot effectively represents one crash point. And then here I'm processing my request log, and that's showing me that when I am under attack, I do actually have a slight increase in CPU time when processing the login.jsp page. So these graphs I've created, they're only actually using a few specific logs. So they're using the resource log, the request log, and my load balancer logs. But Fusion Reactor by default will send information on resources, garbage collection, class loading, memory, sessions, if you configure it, JDBC, things like this. And that's just the logs Fusion Reactor itself sends. You could, of course, then enhance this. So you could send, your database logs, for example, or your balancer logs, whatever you can send. So with the data you have, you can really create very powerful dashboards out of this. And you can render them in a single dashboard and multiple dashboards, whatever works for you. But you have a platform to directly compare data. And if you have an issue, actually view the context for that. So that just about wraps up the demo portion of the webinar. So we've just shown you 4 possible uses of the logs and the log functionality itself. But these are, of course, not the only things you can do. And depending on your situation, there'll be many different uses you can have. The benefit of having these unstructured logs and logs that can have any format you need is that depending on the data you send, you can process it in different ways that's useful to you. So with the logs you have, or if you're writing a new application, the logs you write, think about how you can use them and query them as a tool set as you write them, so you get the most value from these. But we've seen you have dashboards to view the data in single places. You can do broad filters for text. You can zoom into graphs and really investigate issues. You have syntax highlighting, so we try and help you to get the right logql syntax. And you have the power of logql itself, which is a very powerful tool even on its own. You can equally view logs historically as well as live. So you can almost stream the logs live as they're occurring. You have log context, and you can graph and make statistics from fields in the log. So the logs are more than just plain text. They actually provide you with real kind of processing power. So I'm now going to touch on what's coming in the logs. So what we have, we've already built quite a powerful feature set, but there's a lot more coming. So the first thing we're doing is we're working on alerting. So we want you to be able to have queries that select metrics or rates of certain values from the logs. And we want you to be able to configure that as an alert. So that this way, if you have a problem or you have some situations you need to act, you can use the logs to generate these alerts for you. And you can go in and proactively check the data as it's happening. You don't have to wait days or hours later to find there was a problem. And this is going to ultimately help to discover issues before you would discover them as a customer of an application. We're going to implement connections from the different features or pillars of Fusion Reactor, if you like. So we want to be able to say, okay, I'm looking at some metrics and there's a problem. Let's go to the logs, explore the logs and see what's happening. And if you explore the logs and find, oh, it's a problem with, I don't know, request X, for example, you can go from the logs to that particular transaction. So this will allow you to have a complete picture of data. You don't have to focus on just metrics, just transactions, or just logs. It's a full 360-degree view of your data. We want to work on obfuscation so that if you're sending logs from the Fusion Reactor agent, we can scrub your logs of any sensitive or potentially harmful information before it's sent anywhere. So that way we can guarantee that what you're sending is safe and you're not going to have anything in there that shouldn't be there. And this is just going to be basically regex match search. So you could look for a specific phrase or a specific group of characters. That would then trigger the scrubber, and then you won't see those logs or that data in the cloud. And the final thing is pretty rendering. So right now, if you have a stack trace or a blob of JSON or XML or anything like that in the logs, we're not really formatting it. We're showing it as is. But we're going to improve that so that when you are looking at your logs, you have a better visualization of your data and it's much friendlier to read as a user. So just some tips and tricks on what you can do with your logs to make them have more value. So you want to be using fields and values if you can. So using your or setting your labels if you're sending as logs. And if you have logs, you're trying to use the key equals value pairing, because that means we can automatically detect fields and you can then process these fields in logql queries, or if you view the log line itself. The second thing is to try and only log what adds value. So there is a danger with logs that you log too much and then your logs become noisy. And it's actually difficult then to find the relevant information from the data that would actually just kind of hide the important bits, if you like. The third is to proactively improve logs. So if you have a problem in your logs, so for example, the out of memory we saw in the third example, if you want to really diagnose the cause, go back proactively and improve the logging you already have. So think of logs as a constant improvement process, not just something you do once and then you leave there. And the fourth, if you are sending as logs, is to use the correct labels. So what we don't want happening is if you call everything sending to the cloud the same label, you might have a load balancer and an application sending with the same job name, for example. And then you can't differentiate the data you're sending and where it truly came from. So as a final thing, logs can, of course, be tricky. So there's a few kind of concerns we all have with logging. So the first one is that logs can be very large and they can grow very large over time, and they come in a variety of formats. So we want to make sure we're not sending excessive logs and that the log formats we send are helpful to us so that we can actually analyze them and be more productive later on. It can be difficult to correlate events when you're using distributed systems. So using labels, using timestamps in your logs, you want to make sure the structure of your logs allows them to be ordered and queried in a proper way. Now with Fusion Reactor, even if your log doesn't have a timestamp, when it's ingested, we add the timestamp. So we will always give you that time context. Now the third one is, of course, the cost of storing logs. Logs can be, hundreds of gigabytes if you're not careful. So Fusion Reactor itself, we're going to truncate your logs after a month. We're not going to keep your logs forever. But you also just need to be careful the data you're sending isn't too excessive. And the fourth and final point is be careful with your sensitive data. So whether it's personal, financial, anything like that, we don't want that passed up into storage if we can avoid it. Sometimes it may be accidental, but we don't want to have this sensitive data stored in log files. We want to obfuscate it, we want to scrub it, whatever we need to do. So now I'm going to hand over to Nick, who's going to cover where Fusion Reactor is going in the future.
Okay. So before we move to the future, let's just stick with the present for a minute. There's a couple of questions that came in as people have been registering for the blog. And the first question, and burning issue for everybody probably, is when will it be available? As we've said, we're going to start the beta program in a couple of weeks. And again, if you want to join the beta program, please leave your details in the chat, or take a look at fusion-reactor.com/beta and enter your details in there. We believe that log monitoring will be in production by the start of 2022. So in January, we will do the full launch. Second question that everybody wants to know is, what is the cost? Honest answer is we're not 100% sure. We haven't finalized pricing yet, but it's going to be based upon the data volume of logs that you send us, and we're working very hard to make sure that it is extremely affordable. So now we're going to jump into the future and take a look at what is coming next. So observability is one of those things that's been talked about quite a lot in the sort of monitoring space. You can't go on to many APM's websites without seeing it mentioned there. But in order for us to move into this space, we want to make sure that we've got the basics in place, and part of those basics is having log monitoring. So obviously that's why we're launching it today. And thank you, Mikey, for your presentation. It was really cool. So in the coming months, customers are going to see that Fusion Reactor is evolving really, really quickly. as we enter this new world of observability. But let's start by clearing up an issue. Is observability just another name for monitoring? It's all very confusing. Monitors have moved on. Many APMs are talking about observability. Some of them are claiming to offer it. So the two terms have become almost synonymous. Monitoring, by definition, means that you know what you're looking for. You can't monitor if you don't know it's there, right? But what happens when you don't know what you're looking for? And this is where observability comes in. So modern distributed systems, particularly those that are developed and supported by multiple product teams, make it impossible to understand the details of an application's internal state, or even whether an application is performing well for everyone. So the term observability entered into the IT monitoring lexicon and describes, I'm going to read this out, a holistic data-centric approach that emphasizes an exploratory capability and enables identification of unknown unknowns. Now, that came from Gartner, and that's quite a mouthful. So what observability really is, it's about getting lots of data from lots of different sources and making sense of it. Or to put it really, really simply, a monitor is like a fire alarm, whilst observability is like thermal imaging. So observability moves beyond monitoring individual application components and look at the outcomes of the system as a whole. And observability is cool. It has many, many benefits, including it gives you a really comprehensive understanding of complex systems. It gives you smarter planning for app releases and application capacity, because it allows you to do a lot more testing before you launch. It gives you faster problem solving and shorter mean time to repair, which means that you find things faster and you can mend them quicker. It gives you more insightful incident reviews, better uptime, improved performance. But most of all, it gives you happier customers, and it gives you happier customers because observability enables you to repair issues before they affect your customers. Often happier customers also means increased revenue, so you'll start seeing a better return on your investment. You can't really talk about observability without mentioning the three pillars of observability. And the three pillars are basically, they give us a holistic view of what's going on in your application. Metrics, as we've seen, such as throughputs or latency or queue lengths, tell us when something happens, and they're often depicted as a time series. They're a great place to start, and a great place to start to really deep dive from. Traces, or if you're familiar with Fusion Reactor, then when we call them transactions, tell us what went wrong during a specific event, and they give you the detail right down to the method level. So the missing bit from Fusion Reactor, so the last bit in the puzzle, is logs. And logs give us, as Mikey has described, a more contextual view of everything that was happening when an event took place. So now Fusion Reactor has a log monitoring, or is about to have log monitoring. We have all of the pillars in place to move forward, which is really cool. But we believe that the three pillars is really just the start for us. We see them as foundations for growth and for evolution. And we're going to build on them to move beyond the classic sort of app-centric approach of the known unknowns into the new territory of being able to truly identify unknown unknowns. So this means that our customers can be more proactive and solve issues before the customers notice something's wrong. And Fusion Reactor will ingest data from other tool sets and languages, such as OpenTelemetry agents, allowing you to combine Fusion Reactor data with data from other tools, giving you a much greater value and a load more insight. Then comes AI and machine learning, which will allow Fusion Reactors keep you much better informed and potentially even run its own repairs. So customers are going to see that FR is really quickly evolving. But if you're an existing Fusion Reactor customer, don't worry. What it's going to give you is more. It's still going to give you a fantastic deep dive monitor. That's not going to change. We're still going to have a cloud version and an on-prem version for those of you who don't want to send your data to the cloud, or maybe use it to monitor monoliths or older applications. It'll do all the things that our CF and our Java customers love, and it's going to continue to do that. But what it's going to do is give you more. It's going to give you much, much more. And we have a plan in place to bring us bang up to date. And as I've said twice, this is the last time we want you to get involved. So join our beta program at fusion-reactor.com/beta, or get a trial or book a demo at fusionreactor.com. Now, if you're new to Fusion Reactor and haven't tried it before and are interested in joining our beta program, now would be a great time to get a trial so you can get familiar with it before the beta program begins. So we're now going to move over to some questions. So as I said earlier, we've already had some questions sent to us, and so I'm just going to skip through some of these now. So we talked about when it's going to be available, and we've talked about how it's going to be costed. So one of the questions that somebody asked was, do I need to be on the cloud to use logs? Yes, you do. You definitely need to have a cloud account. So when you sign up for a trial, you just choose the cloud or SaaS option. Does it cost more if I have the cloud now? Yes, if you have a cloud account, logs will cost you a little bit more because it's an extra service. As we said before, it'll be based on data volume, but there will be a sort of free volume available. But all of that's to be decided later. If I want to move from on-prem to cloud, does it cost me more? No, absolutely not. On-prem and cloud cost exactly the same. If you're on-prem now and want to give cloud a go, then you can do this really, really easily. All you need to do is go to fusion-reactor.com/switch, and there's a form for you to fill in, and then our customer success team will get in touch with you and they will handle the migration for you, and it'll just take a couple of days. How much data can we handle? Well, we can handle as much data as you can throw at us, really. Whether it's big or small, we have the capacity to just handle a huge amount of data. Another thing you might like to know is that there's going to be no real effect on overhead. We've optimized and compressed binary try that again. We use a very optimized and compressed binary format for sending logs to the cloud. The overhead will be dependent on the amount of data that you send, obviously, but we have been using this now for some time and we haven't noticed a marked change in our overhead. So nothing's gone slower, everything's working as it should be, and we don't see any reason why this isn't going to continue. Last thing is, will my data be secure? And somebody asked a question around security in the questions earlier. We use AWS as our cloud infrastructure provider. Our data sources are encrypted data, and you'll be able to obfuscate data that you send. Now I'm going to hand you back to Mikey, who's going to go through any additional questions. Mikey?
Yes. So I picked up on a few questions in the chat, and I'm going to start with those first. So one of the questions was the query run. So running the queries looks simple, but does it exist on the proper syntax? So yes, and I put a message in the chat for this as well. So Fusion Reactor is using logql. This is actually an open standard query language developed by Grafana. It's not something we've done ourselves. So, and you'll have a link to that in the product as well, but it's using a fully standard logging system, and it will obviously update and add features as Grafana does it. Will the recording be shared later? Yes, it will. And I believe Nick will touch on exactly that later on. Has this covered any insights on how ransomware is being infiltrated around? I don't believe it has, Mark, but I would probably need a bit more context on that one, to be honest with you. And then we also had some questions themselves. So can we say logging is kind of a debug process? Sorry, a pre-debug process. Ultimately, this will depend on what the log content is. So in our case, a lot of the logs we had are almost used as a pre-debug to find the initial cause of a problem, and later investigation is needed. But there's nothing stopping you from kind of logging everything as a debug level already, in which case you can debug straight from the logs. So it honestly depends how you're using logs in your own implementations. We've touched on the fact that Fusion Reactor is all cloud-based currently. So for anyone looking currently in the cloud, you won't see the logging option I was showing. When we enroll for the beta, this UI will be unlocked for you. But as of right now, this is basically available for us internally only. Can this be used in conjunction with another logging service? So yes, it can. We won't be able to connect to the log stores of Datadog, for example, but there's nothing stopping you from sending to both or even sending logs from Datadog to us, and that would be fine. What have we got? If logs are sent to standard out, both Datadog and FR can read them. So yes, if logs are sent to standard out, you could have the Datadog agent and the Fusion Reactor agent both process and send those files to their respective locations. How does this compare to Outstack? To be honest, I wouldn't really know. That's not something I've used before. So I can't really give any context on that, unfortunately.
Okay, I think that's just about all of the questions we have for now. So yeah, we will be mailing out the recording of this webinar over the next couple of days. We'll also be posting an edited version of the webinar where we're going to split it into bits. So you'll have just a demo on its own and the other bits around observability separately, make it a little bit easier. We'd like to thank everybody for attending. It's been really good. I'd like to thank also all of those people who have already registered for the beta program. I've got a number of inquiries from the website, and thanks to Charlie and Mark and anybody else who has put their name in the chat. It's really, really cool. So that's it. We hope you've enjoyed it. We hope you are excited about the future of Fusion Reactor as we are, and we look forward to seeing you all in the next webinar very shortly. So that's it. Thank you very much. Goodbye.
I think, Nick, you're hosting, so you have the end button now. I can take over and do it if you want.